pages on floppy rings. That fungal starts in binary bling. Capacitors doing jazz hands. Resistors juggling tiny rubber bands. CRT screen start to giggle. Keyboard keys do a little wiggle. So the smoke smells like bubble gum. That fungal hits on here. Comes a hum.
Welcome, Swarm, to the stream where pixels flicker and the chattel beat. Though you fluttered off, your presence remains. In whispers of wings and echoes of game. Here in Majenko's space we unite to laugh and cheer through daylight. So the buzz, if you will, of this digital band, here at Mr. Comic, that's the jam.
A schooner is a sailboat, stupid. Hello, I got bored. It's lovely watching stripes on a screen for hours on end, with the odd word maybe showing up, but there's only so much you can take. So, Daft Punkle is streaky now, is he? There's only so much streakiness that I can take, I'm afraid. So here I am. And here you are too. Hello Daft Punkle, hello PJB, hello Swarm, RazPL, GPin. You're the dedicated few. The end! Yes, happy Saturday. Indeed, happy Saturday. The words were the crowning achievement indeed, yes. Right, well, I'm early, so let's get on with some work, shall we? Or just fart. Hello, Chloe.
She's in the zone.
You're the dedicated few. Yeah. Right. I left it last night that it was looking like it was going to be working with our new system. Possibly. Maybe. If we're lucky. So I need to put back in the actual sending MFM code, which is just one comment. And then we shall hook it up to the logic analyzer and see what it is actually giving to us. And see if it is giving us actual, real, proper MFM like it should be. So I pressed go live and now it's broken, yes. No, it is working. Though I did experiment with trying to overclock it earlier, but it did not like it. It wouldn't work. And I think it probably was throwing an exception that the number I was providing was too high. So we'd have to do something strange to it to break out of its limitations if we wanted to overclock it further. So can't be asked. So, sequence of events for today. Put back in the code that we cut out. Test it to make sure that it is giving out the right stuff, and of course it will be giving out the right stuff because it's my code, of course it will. And then we shall look at the what's it thingy by 4 CRC32 code that MJ has dug up for us. We shall experiment with that and see if we can get even more speed out of it. Slice by 4, that's it. Keep wanting to call it divide by 4, but it's not divide by 4, it's slice by 4. Sequence of events for today. 1, 2, 5, 6, 7, 3, 4. Caution, time travel ahead. No, 5 is right out. It's a Dopaz! Thank you for the 30 bits. So this is the sending thread. Put that back in. Big Dog Dopaz. Biggest doggers. Okay, so we have uploaded the new code. And it is still executing, that is good. So let us mount our test disk and see if it continues working. So far, so good. That's a good sign. Yep, that is spinning. I need to fix the head though, to a specific head, which involves connecting up the Arduino to it and getting things executing. Right, so this goes this way around and suddenly it seeks, automatically seeks to another track. That is a good sign. Let's plug power into the Arduino. Okay. Come on, clear properly. Thank you. Okay. So, there are things that may not work here. But we can try seeking. Yep, seeking is functioning with reasonable timings. Look how much faster track 0 is. Ooh.
Wait, am I an idiot? Oh, I'm an idiot.
I am an idiot, thank you.
Champion!
With 50 bits, Chloe Raccoon says.
Cheer 50 up in front.
Up in front indeed, thank you very much for the bits. But yes, and I'm an idiot is, the idiot redeem is supposed to be used for that. And it worked. Track 1 takes almost no time at all to read because it's the very first bit of the file. So I guess it takes no time at all to seek. So if that's the case, there's a huge amount of time taken seeking to the right location in the file. Massive amount of time, like 8 milliseconds just to seek. Now of course if we go to track 0 where it's all coming out of memory, that is just lightningly quick. Ben's seems much more polite, yeah. I could make Ben's happen more often. Large seeking times, yes. Because track 1 takes about 250 milliseconds to load. Track 2 takes 8,000 microseconds to load. Now we jump ahead. Meow, meow. They all take about the same amount of time to load from there. In fact, seeking backwards seems to be slightly slower. But if you don't have to do any seeking, then it just takes almost no time at all. That's interesting. That is interesting. I wonder if there's a way we can optimise that. Because that would be a huge, huge increase in speed. If we can knock out that 8. Anyway, I digress. Which is better than I undress. Let's get the logic analyzer plugged into this. Knocking out an 8 sounds like an issue that would have DOS implications. Okay, so this one is index. Index is that pin there, and we'll go to that ground there. This one is data. Data is that pin there, and we'll go to that ground there. Okay. Now, do I have my USB-C cable here somewhere? I should have. That looks like one end of it. There's the other end of it. Plug that into my hub under the desk here. Let's plug that into the right end, shall we, idiot? Okay. So we are currently on track 0. I hit start, we get an index pulse, we have things here. We're outputting stuff, but that is looking suspiciously like all zeros. Which is not a good thing to see. So let's go up to track 1. This should be coming from disk. And it's still looking like all zeros. Okay. The bot has not said a lot yet, has he? He's mercifully quiet now. The bot is here. He's just very quiet. I've shut him up a lot. Right, so it looks like we're not actually getting any data. Are we getting the right CRC for no data?
Jeep in 24/7.
Yes, we are. We're getting the right CRC.
It is quite pleasant.
So the CRC calculation is working, but we're not loading any data into the array. Use a microscope to find the data. Hello, Dizziac. I could do. Right, so why are we not getting any data? We're getting everything but data. We're getting the header information. We're getting the CRC. Actually, let's just go up a bunch of tracks and then sample and see what we get. all zeros. And we get zeros across the board. Even on track 0, head 0. We are... No, hang on, we're on head 8 for some reason. So why are we on head 8? Head selection doesn't appear to be working properly. Right, so if head selection isn't working, we're not getting data, but we may be getting data, it's just not got any data because the head is wrong. Okay. Let's get some more probes connected and see if the head select stuff is actually getting through to the main processor. Let's grab another one of these. Okay, so 4 to 7 are going to be the head select pins, or signals. Yeah, I want to put these on direct, I think. So I've got 0, 2 and 3 at this end. And 1 is there. Okay. So this disconnects the head select from the rest of the system. So that's 0. And head select 1 is that one, isn't it? Okay. That's head select 1 going into there. Oh, hang on, these need to be this side of the signal path, don't they? Because they're incoming signals. Head select 2 and head select 3. Okay, so back into here. Look to the first dump I gave you a track 0 with supposedly VMS on it, and on that dump, first 3 sectors that also have this magic data, but the rest is happily file system. Well, track 0 is the first 3 blocks are the UIT, this magic data. Then from then on you have debug blocks, which are used for other purposes, one of which is remapping. It's used basically when testing or fixing or trying to recover bad blocks, where it copies an entire track into track 0. reformats that track and then tries to put the data back again. So you would get, if it has done things like that, you would get file system data within there, yes. But only as basically a scratch area. So 4, 5. So 1, 0, 1 we're not using 2 and 3, 4, 5, 6, 7 we are, 8, 9, 10, 11, 12, 13, 14, 15 we aren't. Okay, so we are on head 0 currently. I run a start and those are all low. Let's go up 1 and that goes up, that is correct. Then second one goes up, track 3, or head 3, the first 2 should be high, yeah. 4, the third one here should be high instead, correct. And 5, that's binary 5, 6 is correct. 7, that's all good, and 8, the last one should be high and all the others low. Correct. Right, so the signals are getting through to the Pi. Yeah, it has probably used it at some point for remapping a bad block or something along those lines. Or just in general, whilst operating under VMS, it might do things. But that's the purpose of that section of data, is as a scratch area for doing diagnostics and things. Right, so we're getting the right signals, but we're not getting the right signals. So am I looking at the right pins? I should be looking at 4, 5, 6 and 7. Pin of which are GPIOs 2, 3, 4, 5. That doesn't look familiar. Now I'm looking at 4, 5, 6, 7, which are the physical pin numbers. That's why it's not working. Okay. So that should be 2, 3, 4, 5. Okay, now the most important job.
The combined smell of breakfast foods cooking and the pungency of charring insulation fills the valley. A number of yaks move stealthily through the morning twilight in search of coffee. A loud shriek precedes I think you've got a typo here. A loud shriek accompanies the... I think that precedes shouldn't be there now, should it? A loud shriek accompanies the Dopplering bleats of a receding ballistic goat. As the morning frost begins to clear, more and more coffee geysers erupt, mostly under incautious goats. Through it all, Alison sits on a reinforced deck above the surface, sipping a cup of tea. Morning all. Hello, Alison.
Ben is a coffee geezer. He is indeed. He's a dodgy coffee geezer. Dodgy geezer. How's the Alison today? All teed up. Right. Let's load that up. And see if we now get the correct heads. You should make tea. There's an issue. The issue being you're upstairs and the tea is downstairs. Okay, so we're going to start off. We need to mount our test disk as that format. And we are currently on 000. That is better. If I go up one, we're still on 000 because the signal isn't getting through now. I need to disconnect these ones I've just connected and reconnect the jumpers that connect the signals through to the Pi. Okay. Hey, we have head number one. And head number two is showing. 3. Yeah. 4. Yeah. 5. Yeah. 6. Yeah, that's looking good. Oops, wrong button. 7, 8, 9, 10, 11, 12. 12 is showing. 13, 14. 14 is showing. Now 15 is showing, but there's no head 15, so I don't know what that'll be showing out there now. Anyway, let's take that back down to 0. So track 0, head 0. Turn those off. Hit start. And things aren't working. And I suspect that I crashed the second state machine, the second thread, by overflowing the number of heads. Yes, it had crashed. So now let's remount that as that. And things aren't happy, why not? Because things are still not working right. Okay. Right, this is not doing what it should, and I think it might be being back-powered through the Arduino somehow. So let us try it now. Okay, that has reset now. It really annoys me that there's no reset button on the Pi. There's no way of resetting the Pi. with a button, like every other board has got a reset button on. So I need to make sure that I limit the number of heads. Things are still not happy. Let's reset again. That is now locking up at blob for some reason. Hot Rocks is limited to one head, yes. A coffee geezer with a coffee geezer from Giza, yes. My index pulses appear to be ringing, do they? Right, so something has gone wrong here. Suddenly it won't mount the, or won't load the image. Pop out the card, LS, nothing, put the card in. I didn't do eject. Okay. So we do a mount of that with that format. Suddenly it's not getting past blob. It's a blob. It's locking up on blob. Properly locking up. It's a blancmange. This was working. Why is it not working now? Killed by signal 15. Trying to hang up. Oh, stuff it. Unplug. Plug in. So it never says adding main image slice. So it could be locking up here. Or it could have done something to the SD card. Minicom can't even core dump on its own today. Nope. It can't. So mount that onto there, and it worked that time. Maybe it's wanted a reprogramming. Okay. But we're still saying head 8, hey? We've gone back in time. Oh, of course, it's not plugged in at the moment, is it? We plug in the Arduino. Okay. Right, track 0 we need. Let's home. Seeking. My God, that's going slow. Ah, it's because I've just accidentally ejected the SD card. And I've got to wait for this to finish before I can then eject and reinsert the card. Nearly there. Why would the card matter? Because it's trying to read from the card. It's a pinnacle of unreliable storage, yes. Okay. Let's remount that onto there. And that's when everything goes belly up. Ah, but I was stepping between tracks and it needs to read the next track. Okay, so mounting does not want to work when already mounted. I was just wondering where you were, Ben. The bot has muzzled, yes.
Feel the rhythm, everything's alright. Dancing close, hearts are intertwined. Jammers in the house, we'll keep it tight.
Okay, so when we mount,
Jammers in the house, I love it night.
we delete current image, which I don't think is ever finishing. When we call delete on image, it calls the destructor, which calls purge slices. Purge slices.
Rem the cat just rolled on in.
Hey, Rem Dog.
Jumpers, boards, and wires fly. Old school tech is reached sky high. Flip the switches like a neon glow.
So, purge slices needs to go through the linked list, deleting it as it goes. So it starts off with scan pointing to the head of the linked list. So while the scan exists, we take a pointer, a pointer variable, as the next entry in the linked list and free the current one. Although, hang on, no. These are slice entries, aren't we? We don't want to free, we want to delete, so that it cleans up everything within it. Hey Nano Machines, welcome. Solaris, VMS, haven't seen these in a while, absolutely. Well, at the moment we're working on an MFM hard drive emulator, which I have been designing on and off, based on a Pi Pico 2. And it's not working yet, but hey, that's why we're still working on it. So we delete the current one and set the current one to be what we were pointing to before. So that should just loop quite happily. Hopefully. Let's put some debugging in. It will eventually go. No, it will probably go. The first one will probably go into the PDP-11 because that has no hard drive, whereas the VAX does have a hard drive. Although it will be used in the VAX as testing because that's the only example that I have at the moment. So So I'll be testing it in the VAX, but its main target is to go in the PDP-11. Right, so we're now saying deleted a slice, but now we're doing a delete rather than a free, because the delete should then call things like file close. Nothing on this one because it's only memory, so that's fine, but it'll be closing the file for us, things like that. You finished and started your first solo PCB design last night. Excellent. What were you designing? Boot, because of course it hasn't restarted because it seems to be being back powered in some way. Let's try that again, like that. That should work. Overclocks my compiler. Okay. Let's have a look. If I mount that as that format, it works. Now I'm going to mount that one instead as that format. It's deleted 2 slices, but now it can't get past blob. Simple circuit, just 2 NAND gates and 4 resistors plus some connectors. But still an achievement as a first solo design. Congratulations. Are you sending it off to China to make, or are you etching it yourself? So why is this locking up on blob? It could be because I'm not initializing this in the constructor, am I? So in the constructor, I'm going to set slices to be null. It's all that's needed for linking to MTR 2000 radio repeaters. Ah, cool. So we first mount that one, and then we try and mount that one instead. And it works a lot better now. That's it. Okay, that was the problem. It was not initializing it to null, so it didn't always know that it was null. So it could. This had some stuff carried over from last time, from the previous mount. Okay, so it's a carrot house. Let's plug in the driving Arduino. Okay, that's looking good. Let's go back to our DS view and hit start. And see what's in our first data record here for cylinder naught, side naught, sector naught. Do we have data? No, we don't. We have no data. There should be the UIC in this sector, but it is just straight zeros. Okay, why are we only getting zeros? With the correct CRC. We like your music, Carrot House. We enjoy your music. It's Ben's we don't like. Okay, so we have something strange going on, possibly with either our loading of the data or just our reading of the data. Because this is what we should be seeing at the beginning of that track. There's all this lot. But we're not. Ben or Ben's music. So we are looking at load track is where it's being called. And we're calling find slice track and an offset. So we're looking for a slice that matches or that satisfies track. So in find slice we are iterating through each slice if the start is less than the required track, that should be less than or equal to the required track, shouldn't it? That's probably why it's not finding track 0. The ducking set pretty extreme, so it doesn't really... Yeah. Yes, I do. I have plenty of ducking enabled. It goes almost silent. Extreme ducking coming soon to a pay-per-view sports channel near you. Extreme ducking. No, that was the extreme duckling. Not extreme ducking. Extreme duckling. There's a slight difference. Okay, so we've mounted that. We hit start on there. We have a look at this. And we have data. Look at that. We have data. Data. We have data. Woo. So that is working. Now, why is the rest not working? Or maybe it was working and just the image that I had loaded had nothing on it. So let's go up a bunch of tracks. Hit start. And we have data. I think the image I had loaded before was just blank. This is much more like it. I think that might be working correctly now. Zeros and ones, yes. Lots of zeros and lots of ones. Hello, Childrew. You need to dig out your HT and find out if the local repeater is still alive. I hadn't heard its ident signal in a while last time you used the radio. I've never really done anything much in the way of ham radio. My uncle had a CB when I was younger. I used to tinker with it a bit. But that was about the extent of my radio experience. Yeah, both kinds, country and western. Indeed. You're licensed, but you've keyed up all of once. Yeah. Bacon radio is appetizing, yes. Yeah, I prefer bacon radio to ham radio any day. As opposed to Chloe's favourite, that is sausage radio. And that's a completely different thing. Right, so it looks like now we have correct data. And times-wise, we're still looking at the same kind of values. It is very intriguing, though, that seeking does seem to take a long time. Or does it? No, it doesn't, actually. Things were completely wrong before. Now it's 247 nanoseconds to read the data from the memory. And the first track is still the 7733, so it's not giving me nothing pretty much for the first track and lots for all the subsequent ones. So that was just a red herring from that less than bug. So I think that all works. Amateur nuclear licenses are a bit harder to come by. Surprisingly not, says Hot Rocks, who works in that field. Depends what kind of nuclear you're after. You can't really build your own centrifuge legally, can you? You took the exams back in the 80s. Okay, so now let's see if we can get this lower, shall we? And just stick to smoke detectors, yeah. Bit of americium, never did anyone any harm. So, on Discord... somewhere, possibly. There we go. This isn't the best example I've seen of CRC 32 sliced by 4, hoping is, yeah. But it should get the gist across. So we do an init of the table, which is in 4 chunks. So we're initializing 4 tables instead of 1. Well, give it a go, see what it does. Okay, where's all our CRC stuff? It'd be so much easier once I've started working on the real code and broken it out into individual files for different things. This is in a time-critical section, apparently. And this is doing Okay. Hey, Bumpum. Isn't a 256 long table CRC already one lookup? Yeah, but it's 4 tables at once. Or something, and it's doing 4 bytes at once as opposed to 1. So I don't know if this is really going to do much, but this... no, this is not good. This won't work. Because this requires multiple bytes at once, and we only ever deal with 1 byte at a time. A 32-bit lookup, basically, yeah. But as 4 bytes rather than a 32-bit value. Because this is doing a chunk of data, but we don't work with chunks of data. No, you, Ben. You're a 32-bit lookup. Yeah, that's not necessarily easy. But it might be. Yeah, the problem is some of the values aren't in the data. The header values aren't in the data. So I would have to copy the data into another array that's bigger along with the header values to then do CRC on the entire thing. I could. You merge arrays, yeah. Let's go hash define slice 4. So if we're in the slice 4 mode, then uint 8t star call it buff equals alloca that plus 2. Buff naught equals that. Buff 1 equals that. Mem copy. Buff plus 2, comma, data, comma, that. Then CRC equals CRC32 fast. Buff. The data, len, and the current CRC. Well, that's why we're trying it, to see if it will be faster. It may be, it may not be. It may not even compile. Invalid conversion from void star to uint 8 of alaka. And memcopy data. Data was not declared in this scope, wasn't it? Of course it wasn't. Now it is. Okay. Upload. See what it gives us. We've got about 4.5 milliseconds to beat. It is a little bit quicker. 3.2 milliseconds. So we've knocked maybe a millisecond off the calculation time. If it's doing it correctly. And we have CRC OK. I should say that's working correctly. And it's knocked about a millisecond off the calculation, which is not to be sniffed at when there was only 4.5 milliseconds to begin with. We're down to 3.2 now. That's not bad. Can calculate the first few bytes as is, then jump to the new 32-bit and finish 2 bytes the old way. Yeah. And it already can calculate any non-32-bit sections. So let's try another variant. Where we go a hybrid between the two. Where we take that, then that. I would need to have both systems implemented at once, which would be wasteful on memory, but we got plenty. So I'll be having to build 2 lots of tables. So So I don't know actually about that. Hey Tyler, not going too badly. It's working at the moment. Can this cope with... Yeah, while len is greater than 4, so I can use this same one for individual. Or if I go... create a little header like that, then use HDR2 like that. So we're just doing a 2-byte one, followed by the big chunk.
Ultimate says error during build. Exit status 1. End of file.
Ooh. 2.7 milliseconds. It's even faster. But is that working? It is. CRC OK. And we're down to 2.7 milliseconds. Ooh, we're getting even faster. We can do 97 tracks per second. We're approaching warp speed now. Now, if only we could read faster. If only we could read the data quicker off the SD card. And this is a fast SD card. New glasses, yeah. Bigger print. We want to get that down. Yeah, the bottleneck is reading from the SD card. But I don't think we can speed that up at all, because that's all done through an external library, and that's already optimized as fast as it can, I think. We could put some static RAM, but not enough to make a difference. I had thought about that, Ben, but when you're seeking more than one track at a time, which you do a lot of the time, it becomes pointless because you're just tripling your reading amount. Well, I've got, it's about 128k for one track, and there's half a meg, so I can store multiple tracks. But it becomes pointless as soon as you step more than one track, yeah. I'm working on the RD54 as being the biggest, really, which is 150 meg. The largest RAM that I could feasibly add would be I think they do 16 meg PS RAMs now, don't they? But it's still it's still serial access to it, but faster serial access. So, but I could add PS RAM to it, theoretically. But it won't give us any benefit, really, unless we can store the entire disk in memory. Then there's no point. So we would need 32 is the biggest now they do, yeah. So we would need a whole load of PS RAM chips, all stacked up. This is a 2350, so it's the big brother of the 2040, the newer version. So we'd need basically a couple of hundred megs of RAM, which is not going to happen. Yeah. I mean, we're going fast enough now. I think chasing higher speeds than this is just for pleasure more than anything, really. Yeah. Yeah, but you don't want BGAs and things like that. It has to be SPI or QSPI because we just don't have the pins. I don't really want to be mimicking a few gigabyte hard drive, but theoretically it could if there was such a thing in MFM, but I don't think there is. I mean, we're talking hundreds of megs maximum, really, of what even exists. 150 is what we're aiming at as the biggest. It's actually aimed really at being used for 10 to 20 meg, so you run out of CHS, yes indeed. It's really aimed at 10 to 20 meg, but they can go up to 150 meg, which is what I'm working with at the moment. That size. 159,936,000. Plus another 128k, 130k. Yeah, but if you have 8 bits of sector, then you're doing LBA, and that gets messy.
9 bits. A swarm of dead insects says.
Corgo 69, he's going the distance. He's going for speed.
Thank you for the bits. Right, so if that's going to be as fast as we can go. I mean, 98 tracks per second is fine. It's far, far faster than the RD51 that we're really targeting. It's not as fast as an RD54, supposedly, but in some ways it can be if it does buffered seeking. If it does buffered seeking, then it can be faster, because I can skip tracks when seeking. Greg Brown? Who's Greg Brown? Not a name I'm familiar with. About any member of Cake? Not a band I've particularly heard much of. Cake. He wrote that song, The Distance. Oh, right. No, I'm not familiar with him, I'm afraid, nor Cake, really. I mean, I have heard of Cake, but I've never listened to Cake, so. 56, oh, that's no age. Yeah, it's supposedly 4 milliseconds for with an average of 30 or something, isn't it? Yeah. And we're going at 7.5, 8, 9. We're going at about 10, aren't we? Yeah. So we're just over half, or just under half the speed. Which is fine for me. I'll say if it happens to do buffered seeks, then we're quids in, because it's the same 10 milliseconds to seek from one track to the next to one track to the other end of the hard drive. So I shall have to look up Cake and have a listen to them. How do you refurbish RAM sticks? You rinse them off briefly with IPA. That's about it, if that. You stick them in something, see if it posts, and then say, yeah, that's good. Right, so next we need to sort out the logic stuff going on around it, including drive select, because at the moment it's just permanently selected, I think. And I can't recall if I've got anything hardware wise for that. Because the drive select goes through a jumper into a decel signal. Decel is going into the output enable of all this lot here. So all of these are only coming through when the drive is selected. And that's going from the P1s are yeah, the P1s go on the Pi side, don't they? So all the signals coming out of the Pi only go out to the bus when decel is asserted. Okay. And the signals coming into the Pi for stepping, direction and writing only make it to the Pi when decel is asserted. Okay. But I also have decel going into the Pi, so it knows when it's selected as well. Though with no signals arriving, that shouldn't matter. I shouldn't actually need that signal, but it's good to have it anyway. Oh, hang on. Track 0 goes to P track 0. P track 0 goes to... No, it goes through there. That's okay. P track, that's that direction. Yeah. So I think hardware-wise, that's all fine. We're generating track 0, we're generating index, direction works, Step works. Seek complete works. Ready, am I doing anything? Yeah, I'm doing ready. That should work. So all that's left now then, yes, is the fun stuff, as you say. Writing. And I'm buggered if I'm doing that tonight. Not with 8 minutes left. He sells D cells on the C cell shore. They won't fit, Chloe. So what I could do now, actually, before spending a lot of time implementing the writing, or trying and failing to implement the writing, I should say, is maybe I should bring up the vac station from the garage and plug this into it and see if I can get it to at least begin to think about reading. Because the image that I've got on it at the moment is a VMS boot image, I believe. So it might begin to think about booting. It'll probably fail miserably when it tries to do any writing, but it should at least begin to think about booting. So maybe that's what we'll do on Monday. I'll bring that up on Monday and see if it'll talk to it. The writing is the next step to figure out, yes. I mean, I know how to decode MFM because I've written my own software to do it. It's just a case of... And yes, VMS can boot from a read-only media, but it's tricky, yeah. Boot R51 or whatever to get sysboot, yeah. But the image... I think the normal image will do writing as default. I think the problem is if it's a read-write media, will be writing to the media to say that it's been mounted and things like that. If it's a read-only media, then it won't. But this is a read-write media, even though it can't write. It doesn't know that it's not read-write. But saying that, there's no read-only or write-disabled signal, but drives on VAXs can be set into read-only mode with a button on the front. So it must be able to handle that. So maybe I need to implement the write fault signal, so if it tries to write, it says fault, and it can't. So it should get quite far before going catastrophically bad, yes. I mean, if it begins to boot, then that's a win. So I might need to implement write fault for read-only mode, basically. So yeah, we'll try that on Monday and see what happens. See if it boots, or if it just all goes completely haywire and destroys the entire world. So, yeah. But that's for Monday. So I won't get beyond the page swap file in it, yeah. But if I get as far as that, then that's a win. A world-ending stream on Monday. You're in, absolutely, yes. Entire world, yes. A VAX, of course. And nothing sucks like a VAX. If I get a sysboot prompt type 1, yes. We shall see what we can get. And then we need to look at writing. Gulp. Microsoft sucks more than a vax. Nothing sucks more than Microsoft. Well, actually, there are things that suck more than Microsoft. Oracle, for a start. Although it's a close run thing. So, it's working. It's maybe not completely stable yet, but it is working. Ish. So, Monday we shall find out for sure whether it's working. But for now, I'm going to finish the stream now, I think, because I need to go and do something very important. And yes, I will wash my hands afterwards. If Microsoft made a vacuum cleaner, it would be the only product of theirs that doesn't suck. Yeah, true.
Bitchin'.
Modern Microsoft sure as hell bent to give Oracle a run, indeed. Right, outro time. Ben, get your last fart in quick. You figured out why DSVU is so crash prone with the decoder. It has a memory leak. Oh, nice, or something, and doesn't handle lots of annotations. Wonderful. Right. Outro time. Thank you very much for joining me this evening. Far better than looking at stripes. Absolutely. Well, I think we have progress there. I think we are at a stage where we can try booting something from it, which we shall try on Monday. So wish me luck for that. Ben should be back with us tomorrow evening. He has no clue what he shall be doing. Or last time we spoke, he didn't have a clue what he was going to be doing. Opens room 4x4 door, that's just the zebras in. Too many stripes. More PCB layout, fair enough. A bit of KiCad poking, or KiCad poking if you prefer. So yeah, be sure to join Ben tomorrow. Ben doesn't have a clue, we need a Colin Sell, yes. Colin Sell was in the Guardian crossword the other day. It's not boring us, Ben, we like it. We like a bit of PCB design. You're welcome, Bampan. Just waiting for the bot. There it is.
A massive thank you to everyone who joined the RTmFM Coding stream today. It's been a blast. Huge thanks to Nano Machine Zero, our beloved pet Canadian, G Paradise, Jeeping 24/7, Daft Punkle, Dopus, Chill, Drew, Fotty, McBartface, Ren Dog, Cap, Tirehoot, Chloe Raccoon, Sir Stews a Lot, RasPL, PJ, Bree9, Sound 950, Bampan, the Swarm of Dead Insects, Hot Rocks Girl, Stream Elements for being here. Special shout out to Sir Stews a Lot for being the champion fotter with a whopping 2 farts.
And a big thank you to anyone who subscribed, raided, or followed You All Rock.
Right, I'm off to tidy up some discarded bottle caps.
See you next time.
Oh God, I maybe shouldn't have done that.
Would you mind identifying what you are?